Hi, I'm Michael Cooper with this introduction to the Digital Accessibility Framework project. On this project, I work closely with two other people, Rochelle Montgomery, Executive Director of Accessible Community, and Baron Jordan, Research Scientist at Maryland Initiative for Digital Accessibility. We developed this framework to identify gaps in existing standards and research, identify which parts of the technology stack are most suited to addressing specific accessibility needs, and to re-envision accessibility standards. In this video, I'll walk you through the model we created in the resulting database. I'll also explain how we derive the content and how to use the database. Everything I'll be demonstrating is available online in the list of links that accompany this video. The project is online at accessiblecommunity.org/DAF. There are several pages that explain various aspects of the project: background, framework, matrix, and roadmap. I'll go over each of these and cover the content in each. To start, I want to understand why we saw a need for this framework. The Digital Accessibility Framework responds to several challenges we see facing the field of accessibility. Accessibility guidance is generally developed in response to observed accessibility challenges and established solutions, generally years after the problems emerge. Formal guidelines development is a complicated process, so it can be difficult for some groups to contribute. New types of technologies with new features can expose new kinds of accessibility challenges that haven't been considered yet. And assumptions used in previous accessibility standards might not be applicable to these new technologies. We also need to identify ways to move accessibility solutions lower in the technology stack. Currently, most accessibility guidance places responsibility on content creators. While this is necessary for some situations, many accessibility requirements could be supported by user agents, content management systems, platform technologies, etc. It is much more expensive for all the content developers in the world to address issues compared to the cost of systems addressing them. We hope to demonstrate the benefits to the industry of moving responsibility away from the author when possible. Recognizing that guidance emerging from this framework will be used for technology of the 2030s and 2040s, we need to forecast how technology and its impact on accessibility will change. Digital technologies that provide new types of experiences will intersect in new ways with individual characteristics. The increasing number of new types of technologies will also require approaches to accessibility that may not work with separate assistive technologies and accessibility APIs. Also, new approaches to content alternatives are being developed, and we do not assume that text will always be needed as a universal fallback. To address these challenges, we need an ability to predict how technologies are likely to evolve and a broader knowledge about human variability and how that may interact with the design of new technologies. These goals inform the structure of the framework. The framework is centered around the social model of disability, which positions accessibility needs at the intersection of individual characteristics and the environment. We developed 3 lists that relate to different aspects of how accessibility needs emerge: individual abilities, support needed, and object characteristics. Individual abilities are characteristics of the person using digital content, such as the ability to see or understand numerical concepts. We organize the list of individual abilities into 3 groups: sensory, ability with various senses; physical, body movement of various types; and cognition, cognitive abilities. Object characteristics are properties of the digital content being presented, such as whether it has audio, numbers, movement, etc. We hypothesize that accessibility needs emerge from the intersection of an object's characteristics with an individual's particular ability that potentially creates an accessibility issue. We divided object characteristics into 3 categories. Content characteristics address the perceivable, operable, and understanding features of content itself. Task completion addresses features that relate to a user's ability to complete a task in the digital environment, including impact of their physical location and design for efficient use. Safety includes social constructs like contracts and privacy, and technological complexity of algorithms and disinformation. For any given item in the list of individual abilities, a person might have lower, middle, or higher ability than the population average. The support needed list reflects this with 5 types of accessibility support. Assistive technology, where assistive technology is an expected part of the accessibility solution. Adjust is where the user would adjust the presentation or interaction, such as by enlarging text or reducing contrast. Alternative represents the content or interaction in another form. Avoid is where users need to avoid the content or interaction, such as Caesar triggers. And default, where the access need is met by content presented a certain way or within a defined range. One way to consider the framework is in the context of existing standards. For example, consider WCAG 1.2.4. Captions are provided for all live audio content in synchronized media. On this slide showing the relationships between the individual abilities, support needed, and object characteristics, the highlights show that this indicates that alternative content is needed for this sensory ability, hearing, with a perceptual affordance, audio. Or 2.1.1, all functionality of the content is operable through a keyboard interface. This maps a physical ability with an operation feature, and in this case we expect the default implementation to meet the access need. The intersection of individual abilities, object characteristics, and support needed come together in what we call the matrix. It's a large table where each cell represents an intersection of one individual ability with one type of support needed and one object characteristic. I'll show the table in a moment, but first I want to show what we put into those cells. For a given matrix intersection, we can document one or more guidance statements. These are short structured statements of the user's specific accessibility requirement and what accessibility accommodation will address this need. At the top is a shorter title that's used for links in other parts of the database. The comment on this item link opens a form to submit your thoughts about a specific item in the database. If we add thoughts beyond the statements, they appear as notes after the statement. Then there's a 3-column mappings table, which shows the intersections relevant to the particular statement. References include links to research or established guidelines. The database also supports tags, but we haven't used that much yet. Most of the statements in the database at the moment were derived from established accessibility guidelines to get a starting population of statements for the matrix. The matrix can be found on the data index page. This links to pages for each of the accessibility statements, individual abilities, object core characteristics, and support needed types. At the bottom of the list is the list of the matrix. In this table, individual abilities make up the column headers with groups in the first row. Object characteristics make up row headers with groups in the first column. Types of support needed make up the headers in the third column. These 5 types are repeated for every object characteristic to collapse the 3D model to a 2D presentation. The individual cells in the table represent our points of potential interest for accessibility. Where guidance statements have been mapped to a matrix intersection, they show up in the table with a short title linked to the details page. A tooltip on the link also provides the full guidance statement. It's a large table and can be different to understand at a high level with all the scrolling. The Fit Matrix checkbox scales the table to the width of your window to avoid horizontal scrolling. This of course makes the text very small. The Show Enlarge pop-ups checkbox in this mode activates a feature to pop up the contents of a table cell at full size when the mouse hovers over the cell. As you can see, some guidance statements are mapped to many intersections, and others only a few. The Show Same Statements checkbox activates the feature to highlight all links to the statement on mouse hover or focus. This is a visual representation in the matrix of the set of mappings on the statement page. Multiple instances of a statement are often seen across a row or column of the table. The Show Cell Position checkbox activates a feature to highlight the entire row and column associated with a cell over which the mouse is located. There are nearly 6,000 cells in the table, although only about a quarter of them have data so far. As we fill out the matrix, we can look at neighboring intersections to explore related accessibility needs that could have been overlooked. Over time, we think this will help us to build a comprehensive model of the requirements for digital accessibility. This project is still in early stages. Now that we have this initial concept, we want to engage with stakeholders everywhere to mature the framework. We have several next steps on this. Currently, guidance statements are mapped to established guidelines only by one-way links. We want to build richer mappings to guidelines, and we think this will help us find new insights. We also want the project to support accessibility research. Where research exists related to our guidance statements, we want to make sure that it's fully referenced. In many cases, though, we might identify accessibility needs but can't find research. We think the framework can provide a compelling argument that research is needed in those areas. Ultimately, the framework focuses on lived experience, but connecting that to research is important to accessibility advocacy. With a framework supported by known guidance and research, the real work is to develop new accessibility guidance. Flexible approaches to exploring the data in the framework allow different ways of considering accessibility needs. We want to develop the most comprehensive set of accessibility needs possible. Then we can explore optimal solutions for each of the needs. For a given accessibility need, support might be provided by one or more of hardware, platform operating system, platform software, content development systems, content delivery systems, content authoring practices, and aftermarket content remediation. It is most efficient to deploy solutions at the lowest level of that stack, and we hope the data will help to advocate for that. As we work on this, we may find additional topics to add to the multidimensional matrix. For instance, adding a dimension for language would support accessibility statements that are not universal, but are important to some languages. We may discover other topics like this as we go. For this project to work, it needs engagement from people around the world. It also needs engagement from people with many types of professional knowledge and lived experience. Supporting this begins with translation of our content into multiple languages, and we may need to find or build tools to support participation in a variety of ways. Currently, we have only basic mechanisms to provide feedback. Each item in the database has a feedback link specific to that item, as we saw earlier. On the data index, we also link to a general comment form in which you can put anything relevant. If you want to suggest a new accessibility statement, there's also a link to a form that has more structured input. We hope to enhance our feedback options soon. Meanwhile, please use these to get in touch. Thank you for your interest in this project, not to mention for making it to the end of the video. I hope this introduction has given you a sense of the potential for this project, and I look forward to further engagement.